Okay, so this is exercise 1A. Let's go. Question number 1. The angle made by the line joining the point 2 comma 0. So 2 comma 0 is here, and negative 4 comma 2 square root 3. The line joining these. Okay, so the angle made by this line with the x-axis. So you mean like this angle. And yeah, so like they mean the. Do they mean this angle or this angle? Well, we can find both of them. So what's the slope? Slope is 2 square root 3 upon negative 4, negative 2, which is negative 6, which is negative, so it's like 1 upon square root 3. So yeah, that's the slope, and that's tan theta. And this is like negative tan 30 degree, right? So it's tan of 180 degree plus 30 degree. Now, minus 30 degree. Yeah. So your theta could be 100 and it's like 150 degree maybe, or your theta could be 30 degree, and I think it is 30 degree because this angle is the one that we've been talking about. Oh, there is no 30 degree, then we have to choose 150. So C. Next question. Next we have question number 2 is if A, okay, these 3 points, then the shape of the line passing through A and bisecting BC. Seriously. Okay, bisecting BC, just find the midpoint of B and C. So the midpoint will be 8 upon 2 is 4, comma 4 upon 2 is 2, right? And from A to that point, we want the slope of that. So 3 minus 2 is 1 upon 2 minus 4 is negative 2. That's negative 1 upon 2 is the slope. Tan theta is negative, yeah, slope basically is negative 1 upon 2. And that's all we need, the slope of the line. Yeah, so C is the way to go. Next. Question number 3, if the vertices of a triangle have integer coordinates and the triangle is, wait, vertices of a triangle have integer coordinates. Never equilateral, isosceles. Well, it can definitely be isosceles. I mean, look at this triangle, it's definitely isosceles, right? Where this is 1, this is 1, yes. But it's not necessarily isosceles, right? Yeah, like you could have 2 over there, and this would also make sense, right? So like this being 2, but can this be equilateral? So you have 3 points that, how would that be? So this being equilateral, that's like, say you have 3 points, x1, y1, and then x2, y2, and x3, y3. And all these are integer points, and then square root of x2 minus x1 squared plus y2 minus y1 squared, something like that, right? Yeah, let's not deal with that. Let's in fact think about it in terms of vectors, right? So the vector going from x1 to x2, that will be x2 minus x1 comma y2 minus y1, and the vector going from x1 to x3, that will be x3 minus x1 comma y3 minus y1. Then the dot product of these vectors, that's the same thing as, so okay, that's gonna be like, that's very complicated. It can probably be equilateral, but when would this be equilateral? That's the question. I mean, since like you only care about the differences, like the difference vectors, let's just say that one of the points of this triangle is 0 comma 0, then you will have like 2 other sides. So this is angle 60 degree over here, this is like, I don't know, it's x1 comma y1, this thing is x2 comma y2 or something like that. Okay, instead of saying this, let's go for a parametric form of this. So this, let's say this angle is theta, then yeah, like this thing will, and this thing is r, so this will be r cosine theta comma r sine theta, and this thing will be r cosine of 60 plus theta comma r sine of 60 plus theta and stuff, right? Okay, now what? Uh, Man, I really wanna use complex numbers right now, but then you guys don't know about it, and it just becomes more complicated. So these must be like integer points. So if this is integer, this is integer, this is integer, this is integer, then their differences and stuff, those will also be integer. What's the difference between these two? That's just 2 sine of difference. So like this minus that, maybe that will be uh, sine of 60 degree upon 2, then times sine of 30 degree, because like 60 plus, yeah 30 degree plus theta, and this is just 30 degree, and this must be like an integer. Sine 30 degree, that's nice, it's just 1, so that means sine of 30 degree plus theta is an integer. Hey, but sine of theta is also an integer. So wow, wait, yeah, like no, r sine 30 degree plus theta is an integer, so r sine 30 degree plus theta is an integer. Yeah, and similarly r sine theta is an integer, so their difference must also be an integer. uh where am I going with this? I don't know. Will this even give actually anything nice? No, I don't know. And like similarly you will have cosine and stuff, and okay, I think there can be such triangles which are also equilateral and they still have these coordinates as, like, hmm, there could be these kind of things, but how would we find them? I don't know. This is like more about number theory and less about these lines and stuff. Can it be equilateral? Okay, so question number 3 is an interesting question. I will save it for later because this I think involves some higher maths. Fourth. Okay, the variation of a line passing through the point -3, 2 and parallel to the x-axis. So passing through some particular point and it's parallel to the x-axis. Hey, that's not a big deal. So yeah, it's y equal to 2. That's C. Question number 5. If the slope of a line is 2 and it cuts and intercept -4 on the y-axis, then its equation, so -4 is just like when x is 0, y is -4. You can see this works. Slope is 2, exactly, C is the thing to go. Question number 6. The equation of the line joining what? Sorry, the equation of the line cutting an intercept -3 from the y-axis and inclined at an angle. So this intercept is a signed quantity, by the way. Right? Intercepts are always signed; they are not unsigned, unlike most lengths. The equation of the line cutting an intercept of -3 from the y-axis and inclined at an angle tan inverse of. Okay, so the slope is basically 3 upon 5. So basically, you are saying, look, like y equal to 3 by 5, x minus 3. So 5y equal to 3x minus 15. Is that there? 5y minus 3x plus 15. Yes, exactly. So A. All right. Question number 7. If the line y equal to mx plus c passes through the point 2, 4 and come on, man, seriously. So y minus 4 upon x minus 2 equal to slope, which is 4 minus of minus 5, which is 9, upon 2 minus 3, which is minus 1, so -9. That means y minus 4 plus 9x -18 is 0, right? So just push this over here and then push this back to the left hand side, right? So it's -9, that's why it works. So 9x plus y is 22. That's the line. Wait, you just want like the slope. The slope is 9, and if it's y equal to mx plus c, then seriously, y is just -9x. -2 times -9 is just 18 plus 4. You could have did it like this, then it's the same thing. So yeah, plus 22. C is 22, m is -9, and that's option C. Right, next question. Question number 8. The equation of the line adjacent, sorry, the equation of line inclined at an angle 60 degree with the x-axis and cutting y-axis at the point 0, -2. So slope is square root 3, cutting y-axis at point 0, -2. So yeah, intercept is -2. Y equal to square root 3x minus 2. That's B. These are very basic questions, like these are not high quality. The equation of a line passing through the origin at the point a cosine a comma a sine a. Seriously, come on. Like, y is just x times the slope. The slope is tan a in this case, right? So y equal to tan a times x, which is B, right? Question number 10. Like, this thing is just a parameterized form of a point on a circle. So yeah, and with an angle a. So it's kind of obvious. Slope of a line which cuts intercepts of equal lengths on the axis, it's -1, right? So if the intercepts are of the same length, or actually the same signed value, so like this is a comma 0, this is like 0 comma a, then this slope will be -1. And that's it. All you need is just that. So right, yeah, wait, it's equal lengths. So do they mean the magnitude? In that case, 1 can also work, because we can also have this kind of condition. Then the slope would be 1. But I think they mean like equal signed lengths. So then it's a. Question number 11. The intercept made by the line, this line on y-axis. Come on, just put x equal to 0, right? And that's like y equal to a cosec alpha. So 11th B. Hey, by the way, this thing is actually very like similar to the tangent of an ellipse and stuff. But yeah, we won't get into that. The equation of the straight line which passes through the point 1, -2 and cuts off equal intercepts. So it passes through this point. We just want the equation of that, and cuts off equal intercepts from the axis. So slope is, I think, -1. Then it's like x plus y, and then putting x, like it's x plus y equal to some kind of constant. That's what the line is, right? So putting 1 and -2 over here, you can see that x plus y is just 1 minus 2, right? So this is the general x plus y, and this is the value of c, right? Because it's for at least one x y, so it should always be like that. It's -1, x plus y equal to -1, or in other words, x plus y plus 1 equal to 0. So c works. But if this was a multiple choice, I would try to go for like B or D as well, because it might be possible that they're talking about unsigned lengths. But yeah, like equal intercepts, not equal lengths of intercepts. So this question, right, this question does have that unambiguity thing. So the intercept made by the line on y-axis is double to the intercept made by it on the x-axis. What? Okay, so for intercepts, you can use this kind of format: x plus y upon b equal to 1, right? I mean, it's not like this is the only format, but you can use this format as well. So the intercept made by the line on y-axis, that's when x equal to 0. So y equal to b is double to the intercept made by on the x-axis. So basically like b equal to a. If it passes through 1, 2, so just put 1, 2 into this equation. We just have 1 upon a plus 2 upon b equal to 1, but then b is 2a, so it's like 1 upon a plus, or you can say like 2 upon b is 1 upon a. So this thing is just 1 upon a equal to 1. That means 2 upon a equal to 2, sorry, and then a is 2, so b is 4. So our line was just x upon 2 plus y upon 4 equal to 1. In other words, 2x plus y equal to 4. That's it. That's our line. So 2x plus y equal to 4. That's A. Question number 13. A. You could have also used some other kind of formats like y equal to mx plus c. Anything. It always works. Question number 14. Right. If the point some point bisects the intercept of line between the what? Oh, okay. Then it's equation. So like this is your line, then this is the intercept between the axis, and this point is the midpoint of this segment, right? Then its equation is of that line. Okay, so this thing is what, like this thing is 5, this is 2, so this complete thing is going to be 4 because it's the midpoint, right? And this thing is going to be 10, so x upon 10 plus y upon 4 equal to 1. In other words, 4x plus 10y equal to 40, or you can say like 2x plus 5y equal to 20, right? So that is option B, right? Right, next question. If some point divides the line between x-axis and y-axis in the ratio 2:3, line between x-axis and y-axis, what? Okay, so the line segment between, okay, fine, in ratio 2:3, and the equation of the line will be, come on man, seriously. So it's just like a comma 0 and like b comma, sorry, 0 comma b, these 2 points, it's dividing a line segment between those 2 points in the ratio 2:3. So yeah, like this 2:3, where this point is over here, this point is over here. Then it's just 3 times of this guy, which is 3a plus, okay, so that's 0, so that's 1, and this is supposed to be b over there, and 2b upon 2 plus 3, which is 5, and that's our point. And this point is 3 comma negative 4, that means 3 upon 5 is 3, and 2b upon 5 is negative 4, so a is 5, b is negative 10. So the line was x upon 5 plus, or I should say minus y upon 10 equal to 1, then multiply by 10, so 2x minus y equal to 10. Yeah, so that's option B. All right, next question. Question number 16. The equation to a line passing through this point and sum of whose intercept on the x-axis is equal to -2. What? Seriously? So some of whose intercepts on the x-axis, sorry, on both the axes, okay, fine, is equal to -2, or okay, so like, yeah, 2 upon a minus 3 upon b equal to 1, and then a plus b is -2, like that, huh? So you can say like, okay, b is -2, -a. Putting that into this equation, just get 2 upon a plus 3 upon 2 plus a equal to 1. Man, that's a quadratic. Yeah, that's a quadratic. It's not a good thing. So 4 plus 2a plus 3a equal to a times 2a, which is a squared plus 2a. Ooh, that cancels. A squared minus 3a minus 4 equal to 0. This is like a minus 4 into a plus 1, right? So -4 plus 1 is -3. This is, yeah, I don't need to explain that. So a is 4 or -1, and b for the corresponding values. So b was just -2, -8. So -2, -4, that's -6. Or so there's like 2 such points. Sorry, 2 such lines. Why is that? I don't know. But there is like 2 such lines. Fine, so it's -6 or -1. Oh, so in options as well you have 2 such lines. Well, that's nice. So for -1, this is -3 over there. Cool. So now we got the line. So it's like what? X upon a plus y upon b equal to 1. That's like bx plus ay equal to ab. So b is -6 over here. It's like -6x plus 4y equal to -24, or divided by 2, so -3x plus 2y equal to -12. So which of these options contain at least this line? It's gonna be like 2y minus 3x and stuff. So okay, let's multiply by negative as well. So 3x minus 2y equal to 12, and that's only in option number B. And I think like this will give this guy x plus y equal to, sorry, x plus y plus 1 equal to 0. So still, let's just, no, wait, something's not right about this, because like, yeah, how can that be? If that's -3, then how can this have like x plus y over here? This doesn't make sense. Oh, and this is like 2y. So I made some kind of mistake somewhere. So 2 comma negative 3, yes, and negative 2, right? So a plus b equal to negative 2, then b is just negative 2 negative a, putting that over there, just get this equation. So I don't know, did I make some mistake? It doesn't feel like that. A is 4 or minus 1, then from that b is negative 6, or oh no, look, minus 2 minus of minus 1. Oh yeah, that should be minus 1. So that explains why you got x plus y, and now this should be correct. So yeah, like bx plus ay, that's just negative x negative y equal to ab, which is 1. So x plus y plus 1 equal to 0. Exactly. So b is the correct way. Yeah, sometimes I do make mistakes. Question number 17. This line cuts the coordinate axis at A and B, then centroid of triangle OAB. Right, so just find the midpoint of A and B, and then find like that, or maybe just don't do it directly. Like do it directly, you know? Yeah. Find A and B and then do it. Like what's this? Bx plus ay. Come on, seriously, it's just x upon a plus y upon b equal to 3. So the thing is, it's just 3a comma 0 and like 0 comma 3b and 0 comma 0. These are the 3 points of whose we want to find the centroid. So it's gonna be a comma b. Just add them, divide by 3, it's a comma b. So b, that's a very bad b. Okay, next. Question number 18. The area of triangle formed by this line, okay, x equal to 0, y equal to 0, this is x's, and x upon a plus y upon b equal to 1. Hey, come on, seriously, just a, b, half of that, so half of a into b is just a, b upon 2. Why did I even draw this? Right, so a, b upon 2, that is option number b. Option b, not number, whatever, doesn't make sense. Yeah. 19. The equation of the lines on which the perpendiculars from the origin make angle 30. What? On which the perpendiculars, like multiple perpendiculars and equations, okay, make 30-degree angle anti-clockwise with positive x-axis. So like this line forms area 50 upon square root 3 for this triangle. The perpendicular over here, this makes angle like 30-degree anti-clockwise. So anti-clockwise with the positive x-axis. Yes, exactly. This has slope equal to 1 upon square root 3, right? And you want to find the equation of this kind of line. Hey, isn't that, it's not that hard. So this slope is 1 upon square root 3. So then what's this slope? It's just negative square root 3. So yeah, like y equal to negative square root 3x plus some kind of constant. And when is y 0? That happens when x is c upon square root 3. So this complete length is just c upon square root 3. I say length, but it's sine length. And this sine length is c, right? So the thing is c squared upon square root 3, well, half of that was triangle. That is equal to 50 upon square root 3. So yeah, c is plus minus 10 in that case. Cool, we got it. So y is negative square root 3x plus minus 10. And yeah, y plus square root 3x is plus minus 10, or like plus minus 10 equal to 0, something like that. So square root 3x plus y, exactly, minus 10. Right. Hey, single correct, of course. Then C is the way to go. So next, question number 20. Question number 20 is, if perpendicular drawn from origin on any line makes angle 60 degree anti-clockwise with the positive x-axis, so like slope is square root 3. If the line makes a triangle with, hey, it's the same thing as before, then its equation is, you know what, just make a general form for this. So if the perpendicular makes angle M, like say it's making slope M, then this guy will just have negative 1 upon m, right? Yeah. And the thing is like y equal to negative 1 upon mx plus c. Not the best format. Let's say x equal to negative ym plus c. That's better, right? Or like x plus my equal to c. That's even better, right? So as you can see, this we assign c, right? This is not what we want. Okay, this is not related with this. It's a different equation. Then okay, then when x is 0, y just becomes c upon m. So half c squared upon m equal to whatever area they gave us. Then that means c is square root of 2am, right? And actually plus minus, and then just put that over. So x is negative my plus minus square root of 2am, where m is the slope of this line. So you can say like x plus my plus minus square root of 2am equal to 0. That is the equation. I should have made it before solving the previous question, then it would be useful, but now I'm just overkilling it. It's just 2 questions for which I need to use it, right? But you know, like I will let it sit somewhere in case I encounter more such questions, right? So over here m is square root 3 and it makes area 54 times square root 3, so it's like x plus square root 3y plus minus square root of 2 into an area is 54 square root 3, that times square root 3. So this is just what, 6 into 54, which is 324. 324, it's like 18 squared, isn't it? Right? 18 into 18 is like 64, and 8, which is 114, I think. Yeah. Right, and then 18. So 8, 2, 1 kind of. Yeah, it's 320. What the hell? 64, so 144. Sorry. Yeah, 80 to 18 is of course that, because it's like 9 into 2 into. Okay, you get it. So that's the thing. 4, 2, 1 carried on 3, 324. That's 18 squared. This thing is going to be 18. X plus square root 3y plus minus 18 is equal to 0. So yeah, A works. Nothing else, huh? Fine. It's 20A. Then question number 20. Actually, I will just let it sit somewhere. Right, next. That's not what I want. Okay, question number 21. For a variable line, this line, the locus of the midpoint of the intercept of this line between coordinate axes. So yeah, like x upon a plus y upon b equal to 1, a plus b is 10. Then the locus of the midpoint of the intercept of this line between the coordinate axes. I mean, it's just the locus of the midpoint of intercept. Yeah, that's just a by 2 comma b by 2. So for that point, x plus y is just 5. So C is the way to go. Question number 22. If a line passes through this point and makes angle 45 degrees with the x-axis and meets the line this in Q, then PQ equals. Yes. So through some point makes some angle, so slope 1 meets this line in Q. You know what? Let's just say it's 1 plus r comma 2 plus r, because then the vector going from P to Q, that will just be r comma r, and we can easily find out what that is, right? And let's say that this satisfies this equation, because of what Q satisfies like this line, and it also satisfies the line PQ. So you will have 1 plus r plus 2 times of this guy, which is 4 plus r minus 7 equal to 0. So basically, 4 plus 2r, that's 3r equal to 7 minus 5. Wait, what? Okay, this was 2 plus r, so 4 plus 2r, of course. That's 1 plus r over 2. So that is correct. So this is 5 minus 7, which is minus 2. So it's like this is 2. R is just 2/3. So this is actually just 2/3 comma 2/3. That's the thing. Okay. Then PQ is just the magnitude of this vector, which is 2/3 square root 2. Yeah. And that is A. Alright, next question. Question number 23. A line passes through this point and makes angle so square root of the slope with x-axis. A point on this line at a distance 3 from the point. Oh, seriously, like, okay, this is point 1 comma 2. This is like what length? Distance 3. This angle is 60 degrees, so it's, yeah. Then you can just use cosine and sine directly. No need for using slopes. Distance 3 from this point. Well, it could also be like this thing, so then this would be 3. Right, so what's this? Sine is square root 3 by 2, so it's like 3 into square root 3 by 2 comma 1 by 2. No, sorry, 1 by 2 comma 0. Right. So this is the vector, actually plus minus of that, then this would be this vector as well as that vector. 1 comma 2 plus this vector, that gives us the points, right? And what's this? 1 comma 2 plus minus 3 upon 2 comma 3 square root 3 upon 2, which is like 1 plus minus 3 upon 2. Okay, this might be, oh, so you want to figure out both the points individually, right? Then 1 plus 3 upon 2 is just 5 upon 2, and this would be 2 plus 3 square root 3 upon 2, and 1 minus 3 upon 2 is negative 1 upon 2. Yeah, and this would be 2 minus 3 square root 3 upon 2. Cool. So not negative 5 upon that. That's not correct. 2 plus 3 square root 3 upon 2. Yeah, and 3 upon 2. No, you want 5. So C, I think. 23rd. Shouldn't it be C? I think it should be. Alright, next. So 24, if the points, these two are like opposite vertices of a rectangle, and other two vertices lie on the line y equal to 2x plus c, then the value of c is what? These 2 points are opposite vertices of a rectangle, and the other 2 vertices lie on the line y equal to 2x plus c. Okay. I get it. So a rectangle, huh? And the value of c is. But okay, then this point, sorry, this line also passes to the midpoint of these two, and the midpoint of these two is just 3 comma 2, right? So the midpoint is 3 comma 2 because yeah, and then y equal to 2x plus c, it passes through this point as well, so it's essentially 2 equal to 6 plus c, so c is negative 4. That's it, c is negative 4. That's all we need. So B. 25. Okay, the angle between the lines y, okay, this and that, come on, okay, just forget about these constants. These are slopes. This has slope 1, this has slope square root 3, that means it's 45 degrees, this thing is 60 degrees. So seriously, at least give us like slopes that we don't know what their tan inverse value are. But okay, they gave us these slopes. 1 that's 45 degree, and this is 60 degree. That's just only 15 degrees right there. So 25th A. Question number 26. Okay, the angle between the lines, these lines, come on, these are perpendicular. You can just see that because these are switched and there's a negative. So 90 degree, right? This has slope negative 2 upon 3. This has slope 3 upon 2. So of course these are perpendicular. D. Question number 27. The angle between the lines, this and that, right? So this has slope 2. Thank God, at least there was something sensible. And this is slope minus 3. So 2 comma minus 3. These are the slopes. Yes. So tan of theta, which is the angle between them, that's like tan of alpha plus theta, or actually tan of beta minus alpha, right? And let's just say we talk about the acute angle, then we will have mod everywhere, right? And not over here because it is already positive. If theta is acute, that's positive. It's just mod of this thing. And Basically tan beta is negative 3, tan alpha is 2. Then beta minus alpha we defined it to be theta, which is the angle between these two lines. And this is very obvious, like this equation is very obvious. And yeah, like for finding acute angles, if your beta minus alpha was like obtuse and stuff, just take the mod of that. And then use the trigonometric formula and this will be done. So tan of beta, that's negative 3 minus tan of alpha, which is 2 upon 1 plus tan beta tan alpha, which is negative 6. So that is negative 5 upon negative 5. Hey, that's just 1. Hey, seriously, theta is just 45 degree. Okay, so 26a. Wait, no. That's not. Okay, fine. 27 C. Yeah, that's okay. So 27 C. Exactly. Next. #28. The obtuse angle between the lines y equal to negative 2 and and y equal to what? Seriously, like y equal to x plus 2 has like slope 45 degree. This thing is just y equal to, like, it's vertical completely, and no, it's horizontal completely because x is free. Then this is basically 0 slope, and this is 45 degree. The acute angle is just 45 degree, and the obtuse angle would be 135 degree. It's 28b. The acute angle between, where it go? This, okay, y equal to 3. Once again, horizontal, and this has 60 degree. Okay, fine. So B. Okay, the orthocenter of the triangle whose sides are given by this, and that. Oh, look, 4x minus 7y, 7x minus 4y. These two are perpendicular. Okay, so these two sides are perpendicular. And okay, yeah, this third side with the hypotenuse. Then the intersection of these two lines, that will be our orthocenter, right? So for a right angle triangle, the orthocenter is just the point where all the altitudes match, and that's exactly this point, right? Exactly. And yeah, let's just solve this thing. 4x minus 7y plus 10 equal to 0. 7x plus 4y minus 15 equal to 0. Let's first add this. So should I actually add this? I don't know. Will it give something nice? No, you know what? Just solve it the traditional ways, like multiply by 4 for first equation, 16x minus 28y plus 40 equal to 0. Multiply by 7 for this equation, 49. No, not 49, because this is not gonna work. Well, actually, yeah, 49. So 49 x plus 28y. 7 times, like minus 105, I think. Equal to 0. Then add these. So 5, 1 carried on to 665 x equal to, so 105 minus 40 is just 65. Hey, that's nice. X is 1. Got it. X is 1. Then this thing is like 7 minus 15, that's 8. 4y equal to 8, y equal to 2, y equal to 2. So yeah, 1 comma 2 is that orthocenter that we're looking for. Wait, yes, it should be 1 comma 2. Why isn't it 1 comma? So it's none of these. Okay, that's not satisfying at all. We did everything correctly, didn't we? Yes, so 7 times that is like 49 plus. Yeah, we did everything correctly. I'm pretty sure. Of course we did everything. It's like x equal to 1. Then from there, 4y equal to 15 minus 7, which is 8. So y equal to 2. And it's not there. So none of these. 30D. Alright, next question. Question number 31. 31 is the angle between the lines x minus square root 3y. Yeah, so in the y-axis. Oh, so you can like think of switching x and y and then figure out stuff, like, because just switching doesn't change the angles and measurements. it just changes the orientation, right? So you could think like this has a slope from the vertical as square root 3, then that angle would be 60 degree. That's obvious. Or otherwise you could do it the other way. Like this has what slope 1 upon square root 3, that's tan 30 degree, and the y-axis has like it's vertical, so it's 90 degree, and then 90 minus 30 is 60. So 31st P. 32. If this line and what 32, if this line and this line are perpendicular, then the value of m is common. Like this got switched, this should have been switched, but negative. So negative 3, 32a. You could have solved an equation to get this right, like find the slopes, multiply, and those should give negative 1. Anyway, question number 33. If the line passing through the points, this point, that point is perpendicular to the line y equal to 2x plus 3. Oh, okay, then lambda is. So this has slope 2. This should have slope negative 1 upon 2. So negative 1 upon 2 is lambda minus 3 upon 2 minus 4, which is negative 2. So yeah, lambda minus 3 is just 1. And lambda is just 4. A is the option. Okay, next question. Question number 34. The equation of line passing, like line passing through 2, 3 and perpendicular to the line joining the points, this point and that point. Okay. Yeah, these points like perpendicular to this line. So what's the slope of the line passing through these 2 points? 6 minus 5 is 1. Okay, 1 upon negative 5, negative of negative 6. That's also 1. Yeah, so it's 1 basically. That slope is 1. Then the perpendicular to that is just negative 1. So okay, yeah, like y minus 3 upon x minus 2 equal to negative 1. Y minus 3 plus x minus 2 equal to 0. So x plus y equal to 5, right? And that's gonna be D. Hey, I don't have to write it. Question number 35. Right, so just check. Yeah, 2, 3 fits in this line. It doesn't fit in that line. So it's definitely this one, and neither does it fit in those lines. Next. Okay, what was I doing? Question number 35. Okay, the equation of perpendicular bisector of the line segment joining these two. Okay, just find the midpoint, the slope, and get it done. Ah, come on. Or you could just use something that gives you the perpendicular bisector directly. Like, let's generalize that, in fact. So you have 2 points, x1, y1, x2, y2. You want to find the perpendicular bisector, right? So this midpoint, that will just be, that's like y minus of y1 plus y2 upon 2 upon x minus x1 plus x2 upon 2. This should be equal to negative 1 upon that slope. So negative x2 minus x1 upon y2 minus y1. Wow, it's getting very messy. So y into y2 minus y1. Wow, minus y2 minus y1 squared upon 4. That is equal to, or I should say that plus x into, oh god, x into x2 minus x1 h2 minus 1 minus of x2 squared minus x1 squared upon 4. Man, this is so bad. Why would somebody even want to do it like that? No, just do it the original way. It's much easier than this. Yeah, I thought we would get something nice. We don't. Right? So yeah, what's the midpoint of these? It's just negative 1 upon 2 comma 1. And what's the slope? The slope is 2 upon 3, right? So the other slope must be negative 3 upon 2. That's equal to y minus 1 upon x plus 1 upon 2. So that means, like, yeah, negative 3 times x plus 1 upon 2 is 2y minus 2 multiplied by 2 on both sides. So negative 3 into 2x plus 1 equal to 4y minus 4. So 4y equal to 4. minus 6x minus 3, which is 1 minus 6x. So yeah, like 6x plus 4y equal to 1. That's the thing, which is option C. So 35th C. I thought we would get some nice formula for this, but no, there's no such nice formula. There is a formula, but not a nice formula. Question number 36. If the foot of perpendicular from origin to a straight line is at what? From the origin to straight line is at the point this thing, when the equation of the lines, come on, seriously. So just draw it out like 3 comma negative, okay, draw it out like this. No, like this, okay, 3 comma negative 4, that's somewhere over here. That's like this slope is negative 4 upon 3, as you can see. Then what's this slope going to be? It's just going to be 3 upon 4, and this point is negative, sorry, 3 comma negative 4. We got it, we got the line basically. So y plus 4 upon x minus 3 equal to 3 upon 4. Wow. 4y plus 16 equal to 3x minus 9. So yeah, like 3x minus 4y is 25. Forward that. Where is it? 3x minus 4y equal to 25. Exactly. And this also reminds me of like you know, that kind of thing where you have this vector and its perpendicular is always a constant vector, like to some particular line, and that's like a plane, but this is 2D, so that plane turns into a line. Okay, don't think about it too much. It's just me going over whatever. Okay, yeah, why do I have this over here? 3x minus 4y equal to 25, right? Yeah. So that's 36. A. 37. The equation of the line passing through the point, this point, and perpendicular to this line is, this guy has slope what? This guy, you know what? Whatever. Just switch this 3x plus 2y and let this be equal to some kind of constant. And just put 1 comma negative 1 into this equation to get the constant. So it should be 3 minus 2, which is 1. So yeah, 3x plus 2y equal to 1. That's the line, which is basically A. Next question. Question number 38. Question 38 is the equation of the line passing through the point C comma D and parallel to the line. This, okay, is, wow. So it's just ax plus by plus some constant, say k, equal to 0. Right. And it passes through C comma D. So ax plus by, or let's say this is equal to k. So putting like x equal to what? X equal to c, y equal to t into this, you will get that the k value is just ac plus bd. That's it. That's the whole thing. So like basically a into x minus c plus b into y minus t equal to 0, which is very intuitive, I think. Yeah. So it's like just shifting the line, and then it's through the origin if you shift it. So if that makes sense. Okay, 38c, right? Just let x minus c be equal to x, capital X, and y minus t equal to capital Y, and then this line is going through the origin. Yeah, that's cool. So 38c. Next time we're going to use it directly, because why even go through this constant k when you can do it directly? Right, just find a line to the origin with that slope, shift it to whatever point you want. Question number 39. The equation of a line through this point and perpendicular to this. Hey, it's the same thing. Nice. So yeah, now it's just a into x minus a plus b into y minus b. It's y minus b equal to 0. Right, so it's just ax plus by equal to a squared plus b squared. Wait, what? Perpendicular to this? Okay, that's different. Okay, so perpendicular to this and passing through origin, that would be like bx minus ay equal to 0. And now just put these things. So like b into x minus a into y minus b. So it's going to be bx minus ab minus ay plus ab. So this cancels anyway and still passes through the origin. That is very weird. You know, like, yeah, this is, why is that the case? Why is this passing through the origin? I don't know. Should it? It does. It just does. Yeah. So bx plus ay equal to 0. So 39c. Very weird. Okay. I did it correctly, right? I think so. Let's go to question number 40. If I just go question 40, let's go directly. Yeah. What's question number 40? The line passes through this and perpendicular to y-axis. Okay, so perpendicular to y-axis, that's just along the x-axis. So it's y equal to some constant, x equal to 3. So it's, yeah, it's y equal to minus 2 basically. There we go. Y plus 2 equal to 0. So 40b. Right, question 41. The equation of a line passing through this point and parallel to the line. Right, the same as before. So it's just x minus a upon a plus y minus b upon b equal to 1. So it's like x upon a plus y upon b equal to, so this is 1 1. This is supposed to be 0 over this, right? Yeah, because it passes through the origin, and now just shift it to a comma b. So that's why it is minus a minus b. So it's gonna be 1 plus 1, which is 2. Cool. X upon a plus y upon b equal to 2, and that is this line. So 41b. Question number 42. A line is perpendicular to this and passes through the point. Okay, its y-intercept is perpendicular to this, so it's just gonna be like, and passes to some certain point. Of course, we have been doing this for ages now, right? So it's gonna be like x minus 3y equal to 0. That's the basis, and then we shift it. So to a point is x minus 2 minus 3 into y minus 2 equal to 0. So then now it just becomes x minus 2 minus 3y plus 6 equal to 0. So 3y equal to x plus 4. There we go. Where is it? Oh, it's y-intercept is. So when x is 0, your y is just 4 upon 3. So D, 42b. Cool. Question number 43. The equation of a line parallel to 2x minus 3y equal to 4, which makes with axis a triangle of 12 units can be. Okay, so it's like this is 2x minus 3y equal to c, for example. That's our line. Then x intercept, like, okay, that, call this thing a maybe. X intercept, that will be c upon 2, and call the y-intercept as b. That will just be negative c upon 3. So the area, the signed area, that is, it's half into negative c squared upon 6, and the unsigned area is like half c squared upon 6. So c squared upon 12, that's supposed to be equal to 12. So c is 12 itself, or plus minus 12 maybe. Yeah, that's better. So plus minus 12, and that means 2x minus 3y equal to plus or minus 12. Yeah. So 2x minus 3y equal to 12? Yes. 2x minus 3y equal to 6? No, no, no. 43b. Next. 44. The equation of line parallel to this and passing through the point of intersection of the lines x minus y equal to 4 and 3x plus. Okay, so the point of intersection of that parallel to this line. Fine. You know what? Maybe if you could like make some kind of linear combination of these two and make it such that this would become this, like, you know, like the intersection point has this properties x plus, so x naught plus 2 y naught equal to c, where the actual line that we're looking for is x plus 2 y equal to c. The intersection point of course lies on that line, so it has this equation. It also lies on the other two lines. So it also has x naught minus 2y not equal to 4 and 3x naught plus y naught equal to 7. And what I'm thinking is maybe if we could like alter this like such that we would get this kind of like something. Yeah, is that going to work? No, let's just solve this. So 6x naught plus 2y naught equal to 14. That's like, it was a nice dream I had, but no, it's just better to directly solve this. So 7x naught equal to 18. Yep, x naught equal to 18 upon, no way, that's just getting messed up. 18 upon 7. Then you can use this equation and say, or maybe this equation. So y naught is just 7 minus 3x naught, which is like, oh no, this is getting very messed up. I just need to find what x naught plus 2y is. Hey, I think I know a way. Like, instead of solving for x naught y naught, we could directly solve for c, right? So we set x naught plus y naught equal to c. Maybe we can say like x naught is c minus 2y naught and put that in there. Would that make sense? Maybe. Or can we do something else then? Okay, multiplying this by 2 and this also by 2, this would be 6 and this would be, no way, that's not gonna work. Okay, let's just keep going with this. So y naught is 7 minus 3x naught, and that's just 3 times of this, which is 324, which is 54 upon 7. So 49 minus 54 minus 49, that is at 5, right? So it's negative 5, negative 5 upon 7. So now we know what the point is. What's this value, x naught plus 2y naught? That's just 18 upon 7, negative 10 upon 7. That's like 8 upon 7. That's not a nice value anyway. 8 upon 7, seriously. Okay, so x plus 2y equal to 8 upon 7, huh? Question number 44. No, that's not showing anywhere. That doesn't make sense. Where did I go wrong? So x naught minus 2y naught is 4. That is correct. Wait, was there? No, there is no minus 2y naught. There's just this y naught. Oh no. Okay, I wrote the equation incorrectly. Okay. So now we can solve it once again. Seriously. Okay, fine. You know what? Maybe we can try doing what I was thinking. Now, then we just give 2x and stuff. No way. So just solve it directly. Like 4x naught is 11. X naught is 11 upon 4. Y naught is x naught minus 4, which is 11 upon 4 minus 4. Yeah, which is negative 5 upon 4. So this value, x naught plus 2y naught, that is negative 5 upon 4 plus 22 upon 4. No, no, x naught is 11 upon 4. So it should be 11 upon 4 minus 10 upon 4. And that's like 1 upon 4. So there we go. This should be 1 upon 4. Then that means 4x plus 8y equal to 1. Where is it? 4x plus 8y equal to 1. Exactly. So B. This took long amount of time. Okay, next. Question number 45. The straight line L is perpendicular to the line. This, okay, the area of the triangle formed with line L and coordinate axis is 5. Then the equation of the line will be, hey, I think I've seen this somewhere, like straight line L is perpendicular to this line. That means its slope is negative 1 upon 5, because this has slope 5, so it definitely has negative 1 upon 5. Its area with the coordinate axis is 5. Look at this equation. Nice, very nice. Just some slope. Okay, the slope to which we want the line to be perpendicular, right? Yeah. And what's that slope to which we want to be perpendicular? That's 5. So we want to put m equal to 5 in here, and area is 5 as well. So it's like x plus 5y plus minus square root of 2 into 5 into 5. That's, yeah, that's just 50. So x plus 5y plus minus 5 square root 2 equal to 0. That is our equation. And yeah, so a works, or this also works. Cool. So a. Wow, this did come in handy. Maybe we want to change this equation so that instead of having the perpendicular slope, we talk about the slope itself. Then this would be for any line. You can just find slope, you know the area, then you can just do it directly. Yeah, we could definitely do that. So instead of putting m, we'll just say put -1 upon m, right? Or something like that. But then, okay, will this then work? I don't know. Like when we say area, we mean signed area, right? So how will, okay, whatever, just move on. 46. If 0, 0, -2, okay, these are the vertices of a triangle, and the equation of the line passing through its centroid parallel to the line. Okay, passing, we can find the centroid, of course. Parallel to the line x minus 2y equal to 1. So what's its centroid? It's -2 plus 5 is 3, so 3 is like, that's going to be 1. And this is also 1. So 1, 1 is the centroid, and parallel to this line, it's x minus 2y equal to, so put 1 and minus 2 over there, and that's gonna be -1. There we go, that's the line. So yeah, x minus 2y plus 1 equal to 0. Yeah, that's gonna be D. So 46D. I think we should go till 60 then, because we have already gone this far. Okay, the equation of line which passes through this, what time is it? 7:28. Fine, we can go half an hour more, I think. Question number 47 is done. No, it's not done. Okay. The equation of the line which passes through this and perpendicular to this line. Okay, so it's like x upon cosine theta plus y upon sin theta equal to a. So basically, also, so like, you know, like you could shift stuff. Yeah, like for example, you have 3x minus 2y equal to 0. Then you could shift it, right? You can shift these numbers. So 2x minus 3y equal to 0, and then change one of them sign, right? That would make this perpendicular. Or you could just take the reciprocal. So 1 upon 3x minus 1 upon 2y, and then change the sign. And it's still the same thing, because in the end it's just 2x plus 3y upon 6. And you know what? This method is like useful at times as well. So what are we talking about? We are talking about this line, right? And we want perpendicular to that line. So yeah, like x upon sec theta, which is just x cosine theta, plus y sine theta equal to some constant, say b, like that will be that line, and it passes through this thing. So then you can feed that into it and get the value of b. And that's gonna be what? A into a into c power 4, where c is cosine theta. Okay, so c power 4 plus s power 4. Cool. And so what do you want? Wait, what's all of this? Cosine squared, cosine 2 theta. Oh yeah, you also had to shift. You also had to change it. So to say minus y, then this would be minus. So a into c square plus s square, a into c square minus s square, and guess what? This is 1. So yeah, a into this thing is just cosine of 2 theta. That's exactly what they were saying. So x cosine theta minus y sine theta equal to a cosine 2 theta. Yes. So 47D. Question number 48. Right, the equation of lines which pass through this point and are inclined 60 degree to line something. Okay, God. 60 degree to that line. Oh, hey, that line is already so it's negative square root 3. That's the slope. That means it's 120 degree. And to that, you want this to be 60 degree. So what's this? What's this like? This is 120 degree. To that, you want to be inclined 60 degrees. So like this could be this, right? Or it could be further 60 degrees. That would be like this. Yeah. So this is just a horizontal line. So like y equal to negative 2, that could be one of the lines, which is okay, which is shown over here. Or the other line would have 60 degree as a slope, so that will have square root 3, and this shows over here. So this would just be y equal to square root 3 plus square root x plus say some constant, and then of course this point passes through it. So yeah, like minus 2 equal to 3 square root 3, or you know, like just shift it. Yeah. So we're gonna shift it to this thing. So y plus 2 equal to square root 3x minus 3 square root 3 directly. Yeah, so like y equal to square root 3x minus 3 square root 3 minus 2. Cool. Which you can write it like that, of course. Square root 3x minus y minus 2 minus 3 square root 3 equal to 0. So yes, A works. One comma 2 is a vertex of a square whose one diagonal is along the x-axis. Okay, the equation of sides passing through the given vertex. Oh, one diagonal is along the x-axis, and we are talking about 1 comma 2, like some point over here. So this thing is, yeah, this is 2. That's all we really need to know. The equation of the sides passing through the given vertex. So you know, like this will have 45 degree angle because like obviously, and this has 135 degree angle. So it's just slope equal to 1 and minus 1. And from that you can figure out these sides, right? So it is y equal to x and y equal to negative x. That's through the origin, and through this point you would have y minus 2 equal to say x, then it would be x minus 1, or y minus 2 equal to negative x plus 1 if it's negative x. So yeah, that's like y equal to x plus 1 or x plus y equal to 3. And over here, okay, so yeah, x minus y equal to 1. So x minus y plus 1 equal to 0. That's this line, and exactly. So C works. How do I always see the right option most of the time? I don't know. Maybe they are placed such that people would see them the first time they solve it. Who knows? Question number 50. The equation of lines which pass through the origin and are inclined at an angle something to the line y equal to. Wait, what? Oh, so it's m and then it's again inclined at m. Okay, this is very weird. Yeah. So say m is tan alpha, then m inclined to that. If we go by addition, so like you have this alpha over there, you could either go down, right? So you can go down or you can go up. Yes, so one of them is just this horizontal line, right? And other one has slope tan 2 alpha, and like, okay, how do you find tan 2 alpha? It's just 2 tan alpha upon 1 minus tan square alpha, which is 2m upon 1 minus m squared. So that's one of the things that we can have, right? So they didn't give what point it is passing through, did they? Oh, through the origin. Well, that's really nice, because then it's just the x-axis and the line y equal to 2m upon 1 minus m squared into x. So it's like 1 minus m squared into y equal to 2m times x. Yeah, so 2m times x plus 1 minus, no, right? C works. And x equal to 0, no. Right, so B is the way to go. Next, the length of the perpendicular from the origin on the line square root 3x minus y plus 2 equal to 0 is perpendicular from what? Length of the perpendicular from the origin. Oh, so just that. Come on, seriously. Like, it's just 2 upon square root of 3 plus 1, which is like 1. Huh. B. Just use that formula. Like, everyone knows it. It's for the signed perpendicular from that line to that. You know it, right? You know it, right? Okay. Question number 52. The length of perpendicular from this to that. Once again, the same kind of question. So it's like 3 into 2 is 6, then minus 4 into y is like minus 4 plus 8 upon square root of 3 squared plus 4 squared. Well, that's just 5. Okay, yeah, that's just 5. So, what's this? That's 2. Okay, 2 plus 8 is 10. So this is gonna be 2. Cool. So it's 2. D. Right, question number 53. The length of the perpendicular from, okay, once again, so now just do this mentally. How is it gonna be? It's origin, right? So 0 comma 0. So 1 or negative 1, but the mod of that. So 1 upon square root of 1 upon a squared plus 1 upon b squared. That's like 1 upon square root of b squared plus a squared upon a squared b squared. So that a squared b squared goes up, but then out of the square root it just becomes ab. So it's ab upon square root of a squared plus b squared, and that's c. Look, mentally. That is another excuse for me for like not wanting to write stuff. Most of the time I write stuff because yeah, I have to. But sometimes if you don't, that's better. The distance between the lines, this line and that line. So once again, like you could just find the distance from the origin to this line and from origin to that line and take the difference of those two. And the way to do it directly without having to even think about origin, it's just 13 minus 9, which is 4. Oh wait, it's on the right hand side. So first move it to the left hand side. So 13 minus of minus 9, which is 22. And 22 upon square root of 5 squared plus 12 squared. So 22 upon 30. And that is C. So 54C. 55. The distance between the parallel lines y equal to 2x plus 4 and yeah, so these are parallel, they are saying. Of course. Well, this goes over here just because y equal to 2x. Okay, now we have to write some stuff. So this is y equal to 2x plus 4, or maybe write it like this. 2x minus y equal to 4, and other one is just 6x minus 3y equal to 5. Instead of writing it like that, I will write it like 6x minus 3y equal to 12. And now we can do the same thing as we did before. So 12 minus 5 is 7. I mean, it should be negative 12, negative 5, and the mod of that, but who cares? So this is just 7 upon square root of 6 squared plus 3 squared. And guess what? That's just 7 upon, take the 3 out. So 3 upon square root of 2 squared plus 1 squared, that's 5. So 7 upon 3 squared root 5. Right? That's 12 over there. Exactly 6. Oh wait, it should be negative over there, right? Because 2x minus 5 would be negative 4. Then it's negative 12, and then it's like okay, it's gonna be 17, not 7 in that case, because yeah, 12 minus 5, that's 17. So 17 upon 3 square root 5, and that's option A. No, that's not 3 square root 5. This should be the thing, that is like just multiply by square root 5 on both numerator and denominator. So this is 5, so 3 times 5 is 15. So 17 square root 5 over 15. So D, 55th D. Physics, the foot of perpendicular drawn from this point to this line. Okay. Oh yeah, it's that kind of question. I like I just hate this kind of thing where you have to find foot of perpendicular and whatnot. But okay, just explain some stuff first of all. So x naught, y naught, it's a point, and this is a line, say ax plus by plus c equal to 0. Then the foot of perpendicular from here to here, or in fact any point, for example. So if you want to go like this, or maybe like this, right? So what you do first is you kind of calculate the vector from this point to that point. So this is getting complicated, right? Yeah, I should just present you with the formula and not the proper method. Maybe that would be easier for me, but no, let's do it the good way. So as you can see, say some point satisfies this thing, then if you increase x by like 1 upon a times r, and you increase y by negative 1 upon a times, sorry, b times r, then you will see that these 2 points, like sorry, this point will also satisfy this equation, right? Just try it out. And what that means, since r can be anything, what that means is that if you have a point x comma y satisfying this, from that point, if you like to that point, if you add the vector 1 upon ar, negative 1 upon b r, or negative 1 upon ar, if you can, like, you can switch it, okay? You can change the negative signs and stuff, it still works, right? So if you add this vector to it, that still works, and that means this is a vector along the line. So this is that vector, and this vector ax plus by plus c, that will be perpendicular to it, right? Because the line perpendicular to this thing, that will be like bx minus ay plus some constant equal to 0, and for that the vector similarly would be 1 upon br and negative 1 upon negative ar. So this becomes 1 upon br, 1 upon ar, right? So you can see like this will be the vector perpendicular to it, and you can also write this thing as ar comma br upon ab, and what that means is, in fact, you can get rid of this ab altogether and just say it's just r times a comma b, and yeah, then get rid of this r. So it's like a comma b is a vector that's perpendicular to the line, okay? And similarly for that, for this thing, you can write as b comma minus a. So b comma minus a is a vector that is parallel to the line, and similarly negative b comma a is a vector parallel to this line, right? And now say from this point you want to go to some other point x comma y which is on that line, right? Then what do you do is just take this vector, which is basically, call this thing like delta x and delta y, but delta x is just x minus x naught, delta y is y minus y naught, not anything complicated, right? Just remember the notation, and you take this vector, you make the dot product with other vectors that we already discussed, and that will basically give you the components and stuff, and from there you can figure out what the length of this component should be. So basically, let's just try to do it. This is a comma b, right? So it's going to be a delta x plus b delta y, and that upon, okay, that's the dot product, but this dot product divided by the length of this original vector a comma b, like that will be square root of a squared plus b squared. That's it. This is the perpendicular distance, right? But this perpendicular distance is just, it's not just the perpendicular distance, it's also assigned length. It's assigned length of the vector from this point to the feet of perpendicular, right? So good, we found the assigned length, but what is this actual vector? It's like, it's this thing, a delta x plus b delta y upon square root of a squared plus b squared, this times a comma b, this vector, right? Because we already discussed that this vector is a comma b. I mean, it's collinear with that. So yeah, now we know the magnitude. So upon square root of a, now this is a unit vector, and that works basically. So since now this is a unit vector, it will work. And yeah, that means delta x plus b delta y into a comma b upon a squared plus b squared, that thing is x comma y. And now we can write delta x delta y once again, just how they were. Wow, this was so huge. Okay, so this can be written as sorry, yeah, this can be written as ax plus by into a comma b upon a squared plus b squared minus ax naught plus by naught a comma b upon a squared plus b squared. Now the cool thing is that ax plus by, that is equal to c. Sorry, that's equal to negative c, because look at this equation. If this was like this feet of perpendicular point, it was already there, right? I mean, it was already on the line, and that's why we can write this complete thing as just negative c. And now combining these two once again, you will just have ax naught plus by naught plus c, but negative on the front. And this is actually what the equation should be, but we write it in a different format, right? So our equation is x comma y is negative of ax naught plus by naught plus c upon a squared plus b squared into a comma b. Oh wait, did I mess up something? Like this should be delta x or delta y, I think. Yeah, this this vector that we just calculated, that's not, yeah, that's just a vector, that's not a point. So this minus x naught comma y naught, that's what this vector should actually be. So like this is minus x naught comma y naught. So once again, using the delta notation, you can say delta x or delta y is all of this stuff. And since now you know the coordinates and stuff, you can actually write, instead of writing it like that, you can write two different equations. So delta x is negative all of this thing times a, and similarly delta y is negative of this stuff times e. And like if you don't like it in two different equations, you can combine it by dividing by a and by b. And this is the formula that most of the books and things like give you, that x minus x naught upon a equal to y minus y naught upon b equal to negative ax naught plus by naught plus c upon a squared plus b squared. And now that you know how to do it, I will give you a nice little challenge. Just try to figure out a formula for the point which is like somewhere over here. So it's not just the feet of perpendicular, it's not like it's not the reflection. It's like, say, x times this length. So if this length is, say, L, then this complete thing is L times x. I want you to find what this point would be, right? So give as much time as you want to this question. And yeah, this is actually a nice exercise. Anyway, so where were we? We were at calculate. Yeah, I hate that kind of calculation because this is very calculative calculation, but we have to do it. Just have to. Right? I mean, this equation, does it feel very intuitive? No, right? I mean, you have this a squared plus b squared term. Why is it there? Why is not in a square root? Why are these two terms over here? How are they related with this length? Like, these are not lengths anyway. Why is this even working, right? So it's just a very, very compact form of the actual thing. Okay, so what was the question? 56, right? The foot of perpendicular drawn from this point to this line. So now our x comma y, we don't know that, but our x naught y naught is 7,8. So we will just have x minus 7 upon a. A is 2 equal to y minus 8 upon 3 equal to so negative of ax naught plus b y naught plus c. So 2 into 7, 14, plus 3 into 8, which is 24, minus 4 upon a squared plus b squared, which is 4 plus 9. The nice thing about it is like it's a squared plus b squared, not in the square root. And so we don't have to worry about those radicals. Yeah. And this is 34, so negative 34 upon 13. So from here, x is 7 plus 2 times that, so minus what, like 68 upon 13. Y is 8 plus 3 times that, so minus 102 upon 13, right? So 9 and 12, yeah, of course. So this is going to be 13 times 7, oh god, 7 times 7 and 21, that's 91, and 68 upon 13, and this thing is that plus 13, so 104 minus 60, sorry, minus 102 upon 13, and this is like x equal to I have no idea whether this is correct or not, but we will go with it. So 23 upon 13, comma 2 upon 13. Yeah, that is the thing, and that's A, physics A. Hey, I put the minus sign and everything correctly, right? Yes, I did. Okay, question number 57. Just not have all of this. Question number 57. The coordinates of the point Q symmetric to the point, this point, and with respect to the line 2x minus 3y minus 3 equal to 0. So the coordinates of the point Q symmetric to the point, symmetric. What does that even mean? Oh, like, okay, so the reflection of this point, I think that's what they mean. So yeah, for reflection, instead of having negative, you just have negative 2. The same equation. So now x naught y naught is negative 5 comma 13. So it's going to be x plus 5 upon a. A is 2 equal to y. Y is like, we don't know. Okay, y minus 13 upon b is 3. Sorry, yeah, minus 3 equal to, so that thing ax naught plus e, all of that stuff, but in negative 2. So negative 2 times, right? Now it should become clear why there is a negative 2 over there, because originally it was just one unit of that vector. Now there's two of those vectors together, right? So you want to go from this point to that line and then further, so twice the distance. That's why this thing. Okay, where was that? Question number 57, right? Yeah, this line, and you want to feed this into that. So negative 10, negative 39, negative 3 upon square root of, no, not square root, sorry, 4 plus 9 directly, right? So now we can do it. What's this quantity? This is 13 plus 39, that is, it's like 2 into what? 52 upon 13. Wow. So yeah, that's nice, because it's just 13 times 4, so this is going to be 8. Cool. So x is negative 5 plus 16, y is 13 minus 24. This is 11, and this is negative 11. Wow. So 11 comma negative 11. That's A, 7th A. The line passing through the point of intersection of these lines and origin. Oh, okay, so yeah, I get it. Points of intersection of these two lines and the origin. Yes. You know what? The thing that we were trying before, let's try it now, because it's much easier to like get rid of these constants than getting rid of the xy terms, right? like they're just constants are just multiply and do something and you can get rid of that. Right, so let's say 2 times of that plus this thing. So the whole idea is that you have this 0 comma 0, you have x naught comma y naught, right? The line, like this line, is just going to be ax plus by equal to 0, right? Some kind of line like that. And x naught y naught of course works, so it's just ax naught plus by naught equal to 0. But then it is also passing through 2 other lines, right? So it also satisfies these equations like x naught plus y naught minus 2 equal to 0 and 2x naught minus y naught plus 1 equal to 0, and that means this also satisfies 4x naught minus 2y naught plus 2 equal to 0, and these two combined, that would mean it also satisfies 5x naught minus y naught equal to 0, right? Just add these two, both of them are true, then their addition is also true. And well, guess what, if this equation is true and you want to guess a and b such that this happens, like this line is passing through x naught comma 1. I mean, you know there's only one such line, right? That passes through 2 of these points. And of course 0 comma 0 is like always passing through this. So let's say we'll guess that a is 5 and we'll guess that b is 5, although we actually found that a and b are 5 and -1. So b is -1, we'll guess that. And oh wow, like x naught y naught, it satisfies this equation 0 comma 0. It obviously satisfies this equation because that's why we chose this format. So yeah, that's the line, and there's only one such line, so obviously it is the line, of course. So yeah, like 5x equal to y equal to 5x, that's gonna be a. Okay, the equation of the line to the point of intersection of line y equal to 3. Once again, the same kind of thing. And like, point of intersection of these, just find it actually. Just find it. Put y equal to 3 in there, you get x equal to -3. So it's -3 comma, what, really? 3 comma -3, that is your, oh sorry, no, it should be -3 comma 3. This is your point, the intersection point, and parallel to this line, right? So the slope is, okay, y even do that, just 2 into x plus 3 minus y minus 3 equal to 0, right? So it's gonna be 2x minus y equal to, so okay, not equal to, like plus 6 plus 3, which is plus 9 equal to 0. So yeah, y equal to 2x plus 9. Oh hey, why did I just put the correct thing yet? Okay, so a number 60. The equation of line passing through the point of intersection of the line this parallel to the line. Oh yeah. So like trying the same thing as before, maybe. I mean, I don't want to find what the point is because it looks very horrible. Parallel to this line, huh? Okay. So let's think about it. Maybe we could like simplify the equations first. So 4x minus 3y minus 1 equal to 0. Let's say x naught y naught because we want to do this for a specific point, not for all general points. 5x naught minus 2y naught minus 3. So like yeah, it satisfies both of these equations. So any linear combination of this. And let's subtract this equation from that equation. It will just be x naught plus y naught because we are subtracting that, just get plus y naught minus 2 equal to 0. Okay, and we want to get like 2x naught minus 3y naught somehow. 2x naught. Okay, and let's, okay, maybe we should just solve it directly. No, that's not a good idea. This 4x naught minus y naught. What? No, that's not what we want. No, actually 6x naught minus y naught. No way. No way. Like two of these. So it's like, okay, subtract 2 of that. So this is going to be 2x naught minus 5y naught. Wow, no. No thanks. We want 2x naught minus 3y naught. Not this thing. Minus 3 equal to 0. Maybe we should just get the x naught y naught values. So we already found a simplified equation. We also have this equation 4x naught minus 3y naught minus 1 equal to 0. So why not just multiply this by 3, you know, so like 3x naught plus 3y naught minus 6 equal to 0, and add these equations together. So like 7x naught equal to 7. Wow. I mean, okay, that worked out even though I thought it won't. So x naught is 1. Hey, that's nice. So y naught is 1 as well. So yeah, it worked out. So okay, so the thing is you start solving it, but not having the aim that you want to solve the equation, but having the aim of simplifying it such that you would get the job done. But if eventually it solves, well, that's a bonus. So yeah, so just keep on simplifying till eventually it just solves itself. So there we go. 1 comma 1 is that intersection point, and we want this to be parallel to this line. So yeah, like 2 into x minus 1 equal to 3 into y minus 1. So 2x minus 2 equal to 3y minus 3, and that means 3y is 2x plus 1. There we go. That's our equation. In other words, 2x minus 3y plus 1 equals 0. That should be, oh, C option. Right. So that's it. We did it. 60 questions in what, like 1 hour and 37 minutes. Not bad actually, because I was explaining, so it's okay. It's fine. Then we will be doing exercise 1B sometimes. I mean, my schedule has been really packed. I don't know if I will get the chance to do it. What's this window to J main? Yeah, and don't they give you answers as well? Okay, where are the answers? Wow, there's a lot of stuff over there. So this was one of the easier exercises, I think. And then of course there's exercise 3, which is just nightmare for everyone. I mean, that exercise 3 is like Olympiad level at times. Okay. Exercise 1A, just check these. I won't be checking any of it. 60 questions. I don't have that energy. So yeah, I'll see you guys in the next video. And if there's something wrong, please tell me what went wrong, what I could have done. Anyway, you get it, right? I'm just tired. Okay, so I'll see you guys in the next video.